All right, ladies and gentlemen, let's look at direct variation again. This time we will be looking at a graph. Our graph will always pass through 0, 0, or the origin, because it always starts with 0. Think about it this way. If it's in a proportional relationship, if we're talking about, I don't know, miles per gallon, if you're not driving anywhere, you're not using any gas. If you're buying something, candy bars, you don't buy any candy bars, you're not spending any money. So there's the 0, 0 situation. So for example, I don't know, let's say you get paid $3 an hour. So your graph will start here because if you don't work, you're not getting paid, basically. But if you work for 1 hour, you get paid $3. You work for 2 hours, you get paid $6. You work for 3 hours, you get paid $9, and so on and so forth. So the line would do something like this. And of course, it won't go to the negative because you are getting paid. You won't have to pay anybody your money because then, let's face it, that just doesn't make sense. A direct variation can also go this direction, so just remember that the line will always pass through the origin. So 0, 0 will always be a part of these explanations or this direct variation. Now, sometimes you're going to be given a point, and in this case, remember, it's proportional. So in order for something to be proportional, we have a situation like this, where you have two ratios that are equal to each other. So this is proportional. So in this case, it says, if we're comparing y and x, y is 20 when x is 4. So that if x is what we don't know, we're looking for the value of x, so x will be here, and this is 65. So there are a bunch of different ways we can go about doing this. We can use cross products, or we can simplify. So in this case, I'm going to simplify this first ratio. So 20 is divisible by 4, so this will become 5, and this is divisible by 4, which will become 1. So then our rate at which things are changing is now 5 over 1. So we can write an equation, y equals 5x. So now we can say, all right, well, I know that y is 65, so 65 equals 5x. So now we divide by 5, divide by 5. So 65 divided by 5 is 13. So that means x has a value of 13. Of course, we can check this by putting a 13 here and saying, all right, if I simplify, that's a 1, this is a 5, so we got the same thing. So this is a proportional relationship. We can also graph this. Of course, this graph doesn't go all the way to 65, nor does it go to 20, but if we were to graph this, we would start at 0, 0. I'll switch colors here so it's easier to see. Start at 0, 0, and because our equation was y equals 5x, our slope is 5. So we have a rise of 5 and a run of 1, a rise of 5 and a run of 1, and so on and so forth. So the graph of this line would look like this. Of course, we can also create a table, so we have x values and y values. So when x is 0, so is y. When x is 1, y is 5. When x is 2, y is 10, and so on and so forth. So you can see that, as before, you can multiply times 5 across the table. So this would be times 5, and times 5. So there's a lot of different things going on with direct variations. Let's look at some more. It says, if y is negative 12 when x is 18, what is the value of y when x is 6? So let's actually just set up that ratio of y over x. So we have a y of negative 12 and an x of 18. So we have negative 12 over 18. Let's go ahead and simplify this to see what our most simple ratio needs to be. So when I simplify, I can divide both of these by 6. So this becomes a -2, while this becomes 3. So my most simplified would be -2 over 3. So we can actually say, all right, well, what is y going to be when x is 6? So this may be easy to see here that we're multiplying times 2. So that y would be -4. Let's check this. So I'm going to write an equation. Y equals -2/3, because that was our most simple. Remember, the most simple is what goes here, x. So here we can use substitution and substitute for x. So x, we're using 6. So y equals -2/3 times 6. So I know it's going to be negative, so y equals negative. And let's see, 2 times 6 is 12. Divide by 3 is 4. So there you go. Y equals -4. Let's do another one. Or here's our graph, actually. So if y equals -2/3 x, I can graph this situation. I can also create some x and y values. But let's see what we have here. We start at the origin, so when x is 0, so is y. I'm going to use my slope of -2/3. So I'm going to rise 2, run 3. Rise 2, run 3. Rise 2, 1, 3, run 3, and so on and so forth. I can go the other direction as well to graph my direct variation, pardon me, and my not so straight lines, but you get the idea. So going back to our table here, when x was 3, y is -2. When x is -3, y is +2, and so on and so forth. So I just pulled those points from the graph there. I think we have another one. In this case, we are going to determine whether each equation represents a direct variation. Remember, direct variation looks like this. Very simple equation, y equals kx, or, sometimes we may even see it like this, y equals mx. We've been talking about slope. Remember, k and m are the same thing, essentially. So what I'm going to do is manipulate this equation to see if it's going to look like either one of these. So first thing I see is I have a -7 and a +7. That's going to give me a value of 0. So now I'm going to have 9y equals 2x. That's combining like terms. -7 plus 7 gives us 0. I have 9y equals 2x. So now I'm going to divide by 9 on both sides. So y equals 2/9 x. Does this one look like this one? I would say yes. And our constant, the k, is 2/9. So this is, kind of a two-part answer here. Here's another one, very similar. Our goal is to get y by itself. Remember, we want to know if it looks like this, y equals kx. So our goal is to get that y by itself, so that means I'm going to divide by -36 on both sides. I'm going to rewrite it in a different order. It says y equals, so I have 12x over -36, but of course I can simplify that. They're both divisible by 12, so y equals 1x over -3. Remember, this can also be written this way. This can be written a lot of different ways, actually. It could also be y equals x over -3, or it could be y equals -1/3 x. All of those are the exact same thing, just manipulating the way it looks. So I guess our question is now, does this look like this, or vice versa? The answer would be yes. So that means our k would be -1/3. All All right, one more. Again, we're trying to see if it looks like this, y equals kx. So I'm going to try to get y by itself by adding 12 on both sides. So y equals 12x plus 12. These are not like terms, so we can't combine them. So again, going back to our question, does this look like this? In this case, there would be a no. Because it's a no, there is no constant of variation.